make their own mystery bag.
Oh gosh, that would be dangerous.
Yes, that would be dangerous.
Or really easy to make it empty.
Okay, here we go, 12-2. Cruising on. Trigonometric functions of acute angles. So this is
Acute angles.
acute angles, yes. Acute angles. This is going to take us back to chapter 8, geometry, and we will be doing
Chapter 8.
yeah, trigonometry. So this is going to take us back to, we're going to look at right triangles. We're also going to look at not just a right triangle per se, like just a general right triangle. We're going to look at a right triangle when it's on a XY plane. And eventually, like in 12-5, that is titled Solving Right Triangles. And so that is where you emphasize SOHCAHTOA, if you remember SOHCAHTOA. Okay. In 12-2, it's not that we don't talk about SOHCAHTOA, it's that we are looking at it in terms of on an XY plane. And so, yes, there is still a adjacent hypotenuse opposite, but there's going to be a thing in terms of x and y. And then also what we say is r. So if we look at a right triangle on an xy plane like that, okay, and we look at this angle measure that's formed when we do that, theta. This would be then, yes, you could say here's our angle theta, and you could say this is opposite, if you will. This is adjacent, right? And then this is the hypotenuse. You could say that, it's not wrong to think of it that way, and that can help you remember the variables that we're going to use. So if you say, okay, sine of theta, remember sine is S-I-N-E, but we don't write it as S-I-N-E, we just say S-I-N for shorthand notation, sine theta. And what we recall possibly is that when we say sine of an angle measure, what you're stating is you want to look at the ratio of two parts, right? A ratio is a comparison of two things. You're going to look at two parts of a triangle in relationship to that angle measure. Sine tells us specifically what ratio we want to look at. And that's the SOHCAHTOA, right? And so if you remember that, SOHCAH and then TOA, right? And so with that, sine theta tells us we're looking at the opposite of the hypotenuse. So we could say opposite over hypotenuse for, this is 12-2. What 12-2 is going to introduce is this concept though of, on an XY plane, this value to go from here up to here is a y value. To go from here over to here would be considered an x value. And then the hypotenuse, they think of this on a circle, and we could do a dotted line like this, and that with the center of the origin, the hypotenuse, whatever the hypotenuse is, would be considered like an r value or a radius value. But it doesn't change anything on your calculator, and it doesn't change any type of ratio just because it's a y and an x and an r. It just changes the notation of it. So if I say, what is the sine of theta in terms of x, y, and r, we look at theta, and then we're looking at sine theta, and we know that it's the opposite of the angle, therefore it's the y value always over the r value, like that. Sorry, the dots are in the way, but it's y over r. Then, if we look at cosine, as we recall, when you hear the word cosine, all they're referring to is they're saying, it's asking, hey, what's the ratio formed of the adjacent side to the angle measure compared to the hypotenuse. So when you hear the word cosine, it tells us, hey, I want to compare a ratio adjacent to the hypotenuse with that specific angle. So the adjacent, though, would be x, and the hypotenuse would be r, so it's going to be x over r. And then tangent, technically, tangent to theta, tangent is actually just sine theta over cosine theta. That's another way to write it. And in which case, it is the same thing as, y over r over x over r, like that. And then if we reduce that by inverting your fractions and multiplying, your r's cancel, and tangent theta, if you recall TOA, is opposite over adjacent, or y over, I'm sorry, not r, but y over x. Cool.
Can you go to the office and get a cough drop?
You may. Okay, so with that, we've got the marker here. So when we talk about sine, cosine, tangent, we can either say SOHCAHTOA, or we're going to need to be referencing things in terms of y's and x's and r's. But again, it's just hey, what's the ratio formed? And so when we look at an angle measure, maybe let me discuss this for a second too, since we're right here. There's reciprocals that we memorize. Now the nice thing about the reciprocal is it just changes the name. It doesn't actually change what the ratios are. We're going to flip the ratio. But if I want to look at the reciprocal of sine theta, that is not inverse sine theta on your calculator. If you recall that from geometry, sine inverse, if you recall that, that's sine inverse. That's not the reciprocal. So the reciprocal for sine, all these markers are bad. The reciprocal, we'll try to go back to pink. The reciprocal for sine is just 1 over sine theta. And instead of writing 1 over sine theta, we actually, which if you said 1 over sine theta, it's just going to change this to be r over y. Instead of y over r, it would just be r over y. But instead of looking at it as the 1 over sine theta, they consolidate that, and they say, we're going to call that, instead of 1 over sine theta, they're going to call that cosecant theta. So cosecant theta, which is interesting because we would think that cosecant would relate to cosine, but it doesn't. Cosecant, and we abbreviate it CSC, cosecant, is referring to 1 over sine theta or r over y. When we look at the reciprocal of 1 over cosine theta, that's going to be equal to r over x. And to simplify the notation, we don't say 1 over cosine, we say secant theta. Now, on your calculators, you do not have cosecant, and you don't have secant, and you don't have cotangent. You would just have to put, if I said secant of an angle measure, you would have to say that's 1 divided by cosine of the angle measure. But it's just a shorthand notation, or a shorter notation to write secant rather than 1 over cosine. And then 1 over tangent theta is going to be equal to x over y, and that's just, this one matches its cotangent theta. So that's kind of nice that it's not something else that's unique. So with secant and cosecant, those ones you got to wrap your mind around, those are flipped, meaning usually people say cosecant matches the cosine, but it doesn't. It's 1 over sine, and then secant. And all this would mean is I am flipping whatever my value is. It's just now r over y instead of y over r. Okay. They also have some co-function identity stuff. I'm not going to get into the weeds. Well, I might briefly discuss it, but I'm not going to write that down right now. It sounds kind of difficult, but it's not, but they're called co-function identities. All right, so now with that, I want to, let's take a look at trying to understand a review, because technically this would be review from geometry. Let's take a look at this. If I have a 30, 60, 90 triangle, so 30, 60, 90 triangle, like that. There was two special right triangles that we dealt with, and then one of them was a 30, 60, 90. Okay, so in a 30, 60, 90, there is a relationships that hold true that we memorize. All triangles have special relationships, if you will, but we don't memorize their values. There's only two triangles that we memorize what those values are. Now, with that, if it's a 30, 60, 90, we can't memorize every side length or hypotenuse length because there's an infinite amount, right? This could be 12 inches long, 12.1 inches long, 12.001 inches long, or 8.2 inches long, whatever. There's an infinite amount of possibilities, but we do memorize the relationship between certain things, and that always holds true. So if you recall, just use a numerical value for us, if our hypotenuse was 10, the shorter side compared to the hypotenuse is always, anybody remember? Half, yeah, so this would be 5. And then the longer side, which is opposite the 60, is going to be bigger than the shorter side. Anybody remember by how much? Root 3. Yep, root 3. Always, always, always. So no matter what your numbers are, it's always going to be half and then root 3 bigger. And you can go the opposite direction as well. Like if you knew your short side, you would be able to find the other sides always. So if we gave another example, and I said, okay, 30, 60, 90 again. All right, and then I said, okay, our short side is going to be 7. With one value on that, you don't have to do, you couldn't do Pythagorean theorem initially, but you don't need to because you know that the relationship always will hold true. So if that is a length of 7, the hypotenuse is 14, always twice as big, and then this side is always going to be 7 root 3. So if we were able to, with a protractor, draw 30, 60, 90, you would, and you measured the lengths of the legs and the hypotenuse, obviously on your protractor or on a ruler, you don't have a root 3 on there, but you can measure it out. It would give you the decimal value, and or you can estimate the decimal value. This relationship will always, always, always hold true. All triangles will have a relationship between them. We just don't memorize them. So it's not just that it's a 30, 60, 90. I could draw a, call it a 20, 70, 90 like this. And okay, this is going to be, we're going to call this 16. There is a specific ratio of this relating to this and this relating to this every single time. We just don't memorize it. But there is a relationship. What does memorize it, you don't have to, I don't have to, because there's an infinite amount of triangles. What does memorize it is your calculator memorizes that ratio. They have every single ratio stored there, which is pretty phenomenal, right? Every ratio is stored. So if you were curious, what's the relationship between the little side over here compared to the hypotenuse? That's where you would come over here and say, oh, I'm just thinking about SOHCAHTOA. And I'd say, what's the sine of 20 degrees? And it would tell you what the ratio is always, 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 always. We just don't memorize it. But what we can memorize is not an infinite amount of angle measures and triangles, but what we can memorize is the 30, 60, 90. And so when I look at this, I can state what is the sine of 30 degrees, and you don't need a calculator for it because you can memorize it because you know that relationship is always going to hold true, and you memorize the relationship. And so when we do that, we say, okay, sine of 30, what are they referring to? They're referring to opposite over hypotenuse. So no matter what your triangle is, the opposite side, we can use our numerical values, the opposite is 5 over hypotenuse, which is 10, or 7 over 14, or whatever it is, it's always going to be, what's the ratio always going to be? 1/2, always, always, always. Now you can punch it into your calculator, it's fine to check it. The sine of 30 is 1/2. If you're in degree mode, that's something to make a note of when you start using your calculator. You want to make sure you're in degree mode, not rad mode or radian mode. So there's a radian mode that deals with pies for a circle. So degree mode. Okay, so sine of 30 is always 1/2. What's the cosine of 30 then? Okay, and we can use our numerical values to check this out. What's the cosine of 30 always going to be? Well, cosine is, come back over here, ca. And it doesn't matter if it's, hey, cosine's x over r. Think about this. You can say, okay, you want to call it x over r? Great. Here's an xy plane, right? And here's your x value over your r value. Sounds good. Or mentally say, oh yeah, ca, it's just the adjacent over the hypotenuse. So what's the cosine of 30 going to be? 5 root 3 over 10. Or, doesn't matter, we could use our other example. What is it? 7 root 3 over 14. It doesn't matter which one we use. It'll always be the same ratio formed. And what does that ratio simplify to be? Root 3 over 2, right? So when you look up at the unit circle, in the corner, do you see the value of 1/2 and root 3 over 2 in that 30-degree angle area? Yeah, you bet. Now there's other ones, right? Root 2 over 2, and then you see other ones like flip, or there's the 1/2 and the root 3 over 2, and you see the 1 and the 0, the 0 and the 1. We'll talk about those as well. So you can check your calculator. Calculator probably cosine of 30 when you're in degree mode is not going to give you root 3 over 2. It's going to give you the decimal value of root 3 over 2. Usually they do. Newer calculators might possibly give you a radical value there. But sine of 30 will always be 1/2. So root 3 over 2 is the ratio always formed at for 30 degrees when you're talking about the adjacent side compared to the hypotenuse. It's always root 3 over 2. Tangent, it's not on the unit circle, but you can memorize it pretty easy. Memorize it or just do the math out without a calculator, right? Because we're looking for the exact value. Not on the unit circle, but what's the tangent of 30 degrees? Well, the tangent of 30 is y over x, or opposite over adjacent, TOA. And so, okay, it's going to be 5 over 5 root 3 or 7 over 7 root 3. Doesn't matter. These are the two pictures we drew. And so those cancel. You're left with 1 over root 3, which would simplify to root 3 over 3. Which you do not really have to end up memorizing that this year. Pre-calculus, we talk about memorizing that. But again, it's not hard if you know your sine and cosines. That isn't too difficult. You just have to do a little bit of manipulation to get there. Because the unit circle will memorize, and there's an easy pattern to it, and it's only root 3 over 2s, 1/2, and root 2s over 2s, and then the 1s and 0s, which we'll talk about. Okay? So then, if you think about sine of 30 is 1/2, what if I ask, what is the cosine of 60 degrees? I would say the cosine of 60 degrees, we come over here. If we were to not think of it in terms of x, y, and r, because when you talk about x, y, and r, you have to be using this angle measure from standard position up to the terminal side. Standard, if you remember, we talked about that yesterday, you draw your picture like this and you draw the angle measure like that. So cosine of 60, if you are to talk about x, y, and r, this has to be 60. But if we say the cosine of 60 with this picture, we can think of it as ca, right? So ca, which is, come back over to this picture, cosine of 60 is adjacent over hypotenuse. So what's the cosine of 60 going to be? 5 over 10, which is 1/2. So the sine of 30 is the same thing as the cosine of 60, because as you make the triangle back and forth, if you were to adjust the hypotenuse back and forth here between 0 degrees and 90 degrees, at some point, this side length of 5, as you adjust the radius, that side length of 5 will eventually become a side length of 5 over here. So the opposite 5 will eventually become an adjacent 5 at some point as you move the radius around. So that's right here, I'll briefly mention it, that's a cofunction identity, meaning the sine of theta is equal to the cosine of 90 minus theta. And the book has those all written in there as well. So that if you're like, well, if I have the sine of 30, that's the same as cosine of 90 minus 30, which is cosine of 60. So those are all cofunction identities. Okay. So they do have some of those listed. I'm not going to write them all down because I'm not going to emphasize them too much. And if you come across them in your homework, then you can we can work with those a little bit more from that. Okay. So let's talk here then. We just discussed the 30, 60, 90s. Let's discuss the other one that we memorized, which is 45, 45, and 90. Okay. So with that, we can draw a picture. I can put it on the XY plane like this, right? And so 45 degrees on the XY plane. We pick a length for the hypotenuse. Let's pick, it doesn't matter what it is. We pick 4, okay. If the hypotenuse length is 4, the legs are shorter than the hypotenuse, right? Now, how much shorter are they by? So we're going to divide the length of the hypotenuse by something. So the 4 divided by, anybody remember what you divide it by? Make it smaller by root 2. Yeah, 2. So in the 30, 60, 90, it's root 3, and the 45, 45, 90, it's root 2. Now, we wouldn't leave it as that 4 over root 2. We wouldn't leave it as that. We would just say, oh, that's going to be equal to 4 root 2 over 2. So in this case, that side is 2 root 2. Okay. Now, when you look at the unit circle up there, this, you'll notice on the unit circle you see root 3 over 2 and 1/2, right? We talked about that. But if you look over here, did you see 1/2 listed on this triangle? No. Did you see 1/2 listed? No. 1/2 comes from the 5 over 10, the 7 over 14. So when you look at the unit circle up there at the, I really wish I had a different marker, at the 45 degrees here, right? At the 45 degrees, they have a root 2 over 2, right, and a root 2 over 2. What they're referring to is the sine and the cosine, which, since it's an isosceles triangle, it's going to be the same thing. So if I said, what is the sine of 45 degrees? You go, sine is, let's talk in terms of x, y, and r, just for practice. Sine of 45 is y over r. So if we were using this numerical example, we'd be saying y, which we said is 2 root 2 over 4, which that comes out to be those cancel, right? You're left with root 2 over 2. Cosine is going to be the same thing because it's isosceles. So cosine is root 2 over 2. Okay. So when they talk about the unit circle is and actually here, I should have maybe passed this out earlier. Passing it now, never too late. The unit, so this has a unit circle, trigonometry, a bunch of like formulas, and identities. We're not going to memorize all this stuff, though some of it we will, and I'll discuss, but it isn't too bad. We're not going to memorize most of it. Then on the back side, it says derivatives and integrals. That's for calculus stuff that you don't have to know. It's just all consolidated on one sheet. I'll show this in the video. So the unit circle that I keep referencing that may not, it's in the corner of the video a little bit right over there. But the unit circle here, you can see at 45 degrees is root 2 over 2, comma root 2 over 2. So those are coordinates, if you will, root 3 over 2 and 1/2. Those are coordinates, right? And so x comma y, therefore the first, at 30 degrees, I'll put this back up here, at 30 degrees you see root 3 over 2, and then you see 1/2. Root 3 over 2, that's referring to cosine, because cosine is x over r. The 1/2 is referring to sine, because sine is y over r. And so it goes x comma y. So on those coordinate points, the x value is the sine ratio, and the y value, I'm sorry, the x is the cosine ratio, the y is the sine ratio on all of those. Now it gets a little, not necessarily tricky, but when you see the 0 on there, or I mean you see 90 degrees and 0 degrees, how does a circle, or how does a right triangle, if you will, have a angle measure of 0? We end up talking about that in 12-3 a little bit. So we may wait to jump into that. I want to make sure I try to get through some of this other stuff. Now, with that, they may ask for something. So if they say, hey, sine of 45 is root 2 over 2, which it always is. It's always root 2 over 2. What if they said, hey, what's cosecant of 45 degrees? Well, cosecant is the, not inverse, but it's the reciprocal of 45, right? I mean, it's the reciprocal of sine. So cosecant of 45 is the same thing as what is 1 over sine of 45. All you do is take your value and flip it. So this is equal to 2 over root 2, which would be equal to 2 root 2 over 2, so it's just equal to root 2. So if you have to answer any questions that deal with the cosecant or the secant, you just take your ratio and flip it and then simplify from there. So we will do a problem where they ask a little bit of this. By the way, tangent to 45 is really nice, because tangent, since it's an isosceles triangle, tangent to 45 would be referring to the y value over the x value, which y and x are the same. Therefore, tangent to 45 is 1. So that's a nice one to memorize. Or easy, I would say, to memorize. Again, on the unit circle, you don't see any tangent answers up there. You just see an x and x comma y. You see coordinate points, and those are referring to the ratios of sine and cosine, or cosine comma sine, I should say. Cosine comma sine. Okay, let's give some teeth, if you will, to this, if I may. And let's do a couple of examples that you will have like in your homework. Okay, so in your homework, you will have one. It'll say find the 6, and I'm just starting to erase them. Find the 6 trig functions. The 6 trig functions, sine, cosine, tangent, and then cosecant, secant, and cotangent. The really nice thing is if you can find sine and cosine and tangent, then to find the reciprocals, you just flip the answers, right? So it's not necessarily that you have to memorize a whole lot more. You do need to memorize that cosecant matches to sine or cosine. Sine. So that's the biggest one.
But it sounds like cosine.
Right. That's the annoying thing.
Yeah.
So it must have something to do with, my guess is something with the Latin or something like that it stems from. I've never taken the time to research it, but it is confusing for sure. So they're going to say find the values of the 6 trig functions, and so they give you a triangle like this, okay, and then they give you theta. Now the 6 trig functions are going to refer to, you are not finding theta. You are finding the values of the function, so you're just finding the ratios, okay? So on the mid-chapter assessment of the test, probably what I'll do is I may give you all 6 trig functions so that I know where you're putting the answers, so it's easier to grade, because everybody is going to be forced into, where I put the word sine, you'll have to put the answer for sine. Or I may just give you, like, okay, there's 6 boxes here, and you tell me what the 6 ratios are. Now, what I mean by that is you would need to give me the ratio that relates to the trigonometric function. sine, cosine, tangent, secant, cosecant, cotangent. So what you're going to need to put, I made the boxes small, but what you're going to say is, okay, let's start with the first one. The first one that usually people think of is sine, because it's SOHCAHTOA. So, okay, what is the sine of theta? Remember, I'm not finding theta, I'm just finding the values of the 6 trig functions. It doesn't say find theta. So what we need to do is, what is the ratio of sine of theta? Well, remember, sine is, it's fine to say SOHCAHTOA. I'm going to try to refer to it as y over r. And so we look and say, oh, I don't know y. Well, can you easily find y? Yeah. Either do Pythag theorem or a Pythag triple. What's the Pythag triple for? 3. So you don't know this, that's what they'll test you on, and then you'll say, oh, I'm going to find it by doing Pythagorean theorem or recognize in this case it's a Pythag triple, so it's a 3. Now I have all 3 values, so what is sine theta equal to? What's the ratio? You go y over r, so it is 3 over 5. Now eventually, your calculator, what's really cool is your calculator will tell you what angle measure is formed when you have a 3 over 5, when you have the opposite is 3 and the radius is 5. Your calculator has an unlimited knowledge of telling you, it says every single time you have this triangle, this angle measure will always be the same. And you do that with the inverse sine button, if you recall. But we're not doing that, we're just stating this. So on the test, or mid-chapter assessment, you would put this whole thing. You're not just going to put 3/5, because 3/5 refers to what? Is it sine, cosine, tangent? I don't know. So you would write this out like this, okay? Now, I'll probably put sine theta equals what? And then that way everybody has to put the correct thing for sine. All right, so then we say, what's cosine? So there's one of them. What's cosine? So cosine is x over r, adjacent. So what is it going to be? 4 over 5. And then tangent is y over x. 3/4. Now you don't have to go in order. You could have said sine, and then what's the reciprocal of sine? Cosecant theta, cosecant theta is 5 over 3. Yeah, you bet. So you could have done that right away if you wanted to. Yeah, whatever. And then what's the reciprocal of cosine called? Secant. Again, I'm not going to let you say 1 over cosine, which is true, but I want you to memorize the word. So secant, what's secant theta equal to? Then it's just the reciprocal of 5 over 4, and then what's cotangent equal to? 4/3. So it sounds like, man, 6 trig values. Oh yeah, done. Okay. Stay awake.
Yeah, it's just a cough drop.
Oh.
Funny. It's not putting me to sleep, it's just like, it tastes funny, and so I'm reacting now to the taste.
I understand. Okay, so that was finding 6 trig values. This is saying the same thing. Whatever, we'll call this number 2-1. Number 2 is saying the same thing, but it's going to say find the 6 trig functions, values of the 6 trig functions of an angle theta in standard position whose terminal side passes through P. And then they're going to give you this. So, in other words, I could write all that down, but it's a mouthful. They're stating, hey, find the 6 trig functions that relate to an angle measure from standard position whose terminal side goes through 5, 5. So a quick little picture can help us, right? We go over 5, up how far? 5, and we say, okay, and it goes out like that, and that's theta. Okay, and then so we're making our own right triangle is all we're doing. And then we're giving it a coordinate point rather than just already stating the side. Here they stated the side, but actually what would the coordinate point out here be? We didn't write it. But what's the coordinate point right there?
4/3.
Yeah, 4/3, right? So it's the same thing. We're doing the exact same thing on this. So we say, okay, over 5, up 5, That's the coordinate point, right? What do we need to solve for in order to find all 6 trig functions? Hypotenuse, yeah, this is not a Pythag triple. So, but simplest radical form, you don't want decimal, right? So you can use your calculator if you want to find it, but you need simplest radical form. What do you get?
5/2.
5√2. So you have to do a little bit of work to get 5√2. And then we just say, okay, what is the sine of theta equal to? Now, this is also in simplest radical form, so some calculators will do it for you. You might have to do a little bit of work. But we go, okay, sine of theta is y over r. And then we say your calculator can do it for you, or you can say, wait a second, I know that. Those cancel to be 1, so you have 1 over √2. So therefore, it's going to be √2 over 2. And then you're like, wait a second, I've seen that value just recently. Oh, well, yeah, because if this is isosceles, what's the angle measure here? 45, yeah. So what do you know cosine is without, as you start to memorize this, what do you know cosine is then? Without having to write the whole thing out, it's √2 over 2. And then what do you know tangent is? This one's pretty easy. You could even, you could just go y over x. What's tangent relate to? 1. And then you have cosecant. And then you have secant. And then you have cotangent. Love cotangent here. Why do we love cotangent?
Still 1.
Still 1, right? 1 over 1 is 1. So cotangent is just 1. And then we did discuss earlier what, I think we did one, right? Cosecant of 45 degrees. So we know that actually ends up being √2. And if cosecant's √2, secant's also √2 if you do your math, right? Again, that's stemming from not to just assume that we understand what's going on, or we say the reciprocal 2 over √2, which would be equal to 2√2 over 2. Cancel and you get √2. Again, the purpose of simplest radical form, I don't know if I discussed, but it came from long before like the usage of calculators. This type of work, in this case, 2 over √2, simplifying √2 is actually simpler, but a lot of times it doesn't look simpler, but it was easier to do division and multiplication when the radical was in the numerator. I looked it up and researched, and it actually made sense. I'm like, oh, that actually makes a lot of sense. With calculators, it doesn't make a whole lot of sense. So that's why the newer textbooks and stuff, because so much of our stuff is calculator based. But an entire system of mathematics starting out was all based off of simplest radical form, so we still memorize the process to get there with some of those. But simplest radical form always doesn't look simpler. Okay. Making maybe a little bit of sense?
Yeah.
Possibly. People get really confused with trig, but if you can understand, trig is simply taking an angle measure in a triangle and stating the ratio based off of sides, right? Based off of that angle measure. Then it's really, hopefully that makes a little bit of sense. They're going to give you this chart, sine theta, cosine theta, and then tangent theta. They're going to give you this. What? Yeah, that's it.
The office
Office will have some. Okay. Well, see the old finish it off the old right here. so what they're going to give you here is this chart: sine, cosine, and tangent. All right, and then they're going to have this, and they're going to have this. Okay, and then they're going to give you, let's go with like this one. You say this, like that. So what we need to do for this problem, we'll call this problem number 3, let's say. 3 is referring to these two blanks. So what they're telling you is the cosine is 1/2. They want you to figure out what is the sine and the tangent, what ratios are we making, okay? So that's what they're asking. So if the sine or cosine is 1/2, one of the ways to do this is if you have all your values on the unit circle memorized, you can just crank this out without, just piecing together the unit circle. If you're like, the unit circle, I don't have those memorized, we can go back to our roots here and say, okay, cosine of theta is equal to x over r, right? And so if we state that, and we state that it is equal to 1/2, which it is in this problem specific, what do I know my x value is equal to? If you just look at this, it's equal to 1. What do you know my r value is equal to? 2. And so if you think about that, then remember you're just setting up a right triangle. X is 1, r is 2, and then what's the only thing you don't know?
Theta.
Y. Well, and theta, you are correct. You don't know theta. So we say, okay, what's y equal to? That's our goal. So to figure out y, how do I find y? By theta, right? And so what is y equal to?
Root 3.
Root 3, yeah. Which when you see 1/2 and where it's relating to the hypotenuse on the side, you know it's 30, 60, 90. Now in this case, we might describe it as a 60, 30, 90.
Yeah.
Right, which we haven't been drawing, but that's okay. You don't have to memorize that. Okay, so now if we know y is root 3, can you fill in your values? You bet, because sine, what is sine referring to? Sine, or I've erased it, but sine is y over r. Or you have your picture drawn, and if you need to think SOHCAHTOA, that's fine. Sine is opposite over adjacent. So what is it going to be? Root 3 over 2. And then tangent is?
Opposite.
Yep.
Oh, root 3.
Yeah, root 3. Root 3 over 1, but if you wrote that, I'm not going to mark you wrong. We could just write it as root 3 though. Makes sense?
Yes.
So you just take your fraction and figure out x and y. Or, maybe we should give you a different one. Should we give you a different one? Sure. What if we gave you root 161 over 8? Ew. Okay, so now we'll call this like number 4, right? Because it's another set of problems. Now we need to figure out what sine and cosine are. If they gave you tangent here, what is this value? Opposite.
So the
Hypotenuse is 15.
or
Okay.
y.
It's your y value, so y is equal to root 161. What is this? This is your x. What is x equal to? 8, and then col.
The hypotenuse is 15.
So our value is 15. You just did pi theta theorem, right? A squared plus b squared is equal to c squared. And now you got your 3 values. And so what is cosine? Cosine is x over r, 8 over 15, and then sine is?
Y over R.
Yep. 15.
Yep, 15. Okay, and drawing a right triangle could help with that too, so you can think in SOHCAHTOA terms. If you, so get started on this, we won't have it due on Monday. There will be I'll do a couple, maybe like one other problem from the next numbers, like you have 21 through 29, there's a couple problems in there that might need a little bit of help with. And then we'll go on to 12.3 on Monday as well, okay? Eventually, you don't need to work on it this weekend, but eventually that unit circle, you will have completely memorized, and I have a quiz on it. And I'll show you what the quiz exactly looks like, so you know exactly what to prepare for. And I'll give you a blank quiz, and then you prep for it, memorize it, and then usually what I do is we take 2 of the quizzes and then average them together. So you have a couple times to do well on it. So, but not happening Monday, right? So we're probably maybe late next week, but I'll give you a heads up and show you what the quiz looks like and everything from there.
I'm not talking about that blue marker there. Oh, the blue. There's no. Where's it there?
Yeah, take that.
Thank you.
Thank you, Michelle.